Hello and welcome to the final session in our Introduction to AI series, AI software for the office. Today, we welcome ex-Cool, who've been with us many times. And we also welcome for the first time Infrared City, a startup that is really shaking the world with its innovation. Angelos Kronos has been on before, as indeed has Theodoros Galanos, and today we welcome Juana. Today, then, we're going to have two sessions, one with X-Cool and one with Infrared City. Please send your questions to the YouTube chat and we can relay them to our two speakers. So, Juana, it's great to have you here. Welcome.
Thank you. It's great to be here.
Over to you. Over to you. Let me just unshare my screen. There we go. Okay.
Fantastic. I will share my screen, and in the meantime, I might do a very short introduction as well. Give me a second. I will share the whole screen so we don't have interruptions. Sorry. Indeed, my name is Juana Todt. I am one of the co-founders of Infrared City, and in Infrared City, I'm responsible for the product, for leading the product in the in the direction that will manage to fulfill most of your needs, the audience. So this is why also interaction with you and having your questions and the ability to learn from what our users need is very important to us and to me in particular. A little bit of introduction, just as I have never been on the on digital futures before. I am an architect originally from Romania. I have experience as um, an architect in a very traditional way, working on the very large and the very small scale of buildings. And I've noticed a few common trends during my many years working as an architect. I've noticed a few common trends of frustrations and difficulties that we have in delivering, organizing ourselves and delivering projects in a way that achieves all our full desires or allows us to achieve the full intentions of the project, but also and these were actually the ones that were more impactful to me. I've noticed a lot of frustrations and a lot of difficulties in how we communicate with the client, how we are able to present the necessary data that will support our project or our designs, and also how we are able to ensure that the designs that we are coming up with are actually the ones that will achieve all the goals beyond the financial and the aesthetic. This is kind of the framework or the mindset with which I decided to step out of the architecture practice as such and turn into technology and understanding how we can develop and apply automation and tools to enable us to design better and communicate better. This led me to first study and then teach a number of seminars, studios in AIAC in Barcelona. I particularly was in charge of seminars and even more studios that were helping students look at and understand how to develop AI solutions for the practice, for the AAC. So starting from algorithmic design to kind of AI studios or particularly in this Master of AI for Architecture, which is one of the newest masters launched at AIAC. And within the same kind of space of ideas is where I was also starting to look into developing products or software solutions that would help solve some of these problems that I encountered and my colleagues encountered, and so on. From this sort of a few years of collaboration and learning more and getting a chance to develop, I found the team of Infrared City that was actually already an established small team developing a research project in the AIT, and this is how Infrared City kind of started as a project put together by my colleagues Angelos Kronis, Theodore Galanos, within the City Intelligence Lab in the Austrian Institute for Technology, where they asked a very powerful question, whether we can enable more accessible environmental simulations by using AI. And particularly at that time, they were looking at empowering CFD simulations with an AI prediction, therefore slicing the time to produce the simulation to fractions of what a full CFD simulation would be. This project was, of course, very successful in its research phase, and this has developed later on as a product that was initially tested and proven with a number of customers and within a number of interesting projects that some of which I will show. And of course, the success of the CFD simulation project led to us starting Infrared City, which is a much bigger vision. Is a vision where we want to enable environmental simulations and actually sustainable design with these AI-powered tools. So since these early beginnings, we have founded Infrared City and developed the very first open available version of the product, which is what I will show you today. We are, of course, only starting on our journey, so we are developing much more features and tools to complete the experience of what we like to call an agile, sustainable design. Although we don't really like to look at these numbers, and they are kind of causing unease, I would say. It's important to recognize where we are today, noticing that every year of the past few years of our history has been the warmest year on the planet. And we are now reaching yet another record this year. All the effects of this heating up and the climate change are actually costing us very heavy price, both in terms of actual dollar amount, but even more importantly, in terms of deaths related to climate crisis. At the same time, we recognize that while our industry is one of the most impactful in terms of the greenhouse gas emissions, we still need to continue building. Building and constructions are essential to our development and to our ability to continue growing as a society, and especially in the context of our shift to the cities, where it is predicted that in the next 2 decades, 70% of us will live in cities. So there is a large number of constructions required to cover up the upcoming needs. To be able to do so, to build and to continue building in a way that both promotes our growth, but also does it in a respectful and a well-adjusted, well-adapted way to our environment without causing further impact. We believe strongly that climate-informed design is an essential way to achieve the optimal design solutions. We know that climate simulations are required to inform designs, particularly in the early steps. However, what we've experienced in all of us as founders in our work experience, also all the uh, users that we have spoken to, they all confirm the same thing. Um, Environmental simulations at the moment are very expensive to achieve. They often lack very complex skills that are not necessarily always available, mostly not in extensively within the design team. They are often extremely slow and almost always very hard to integrate with the current design workflows, causing even further time delays. So we recognize that there is a need to unlock these barriers and to democratize access to the climate-informed designs as a way for building more sustainably. Now, at the same time, one graph that I like to show, although it's a pattern of a graph that I'm sure you have seen a lot, and it's relevant in many different contexts, particularly in the AEC, is understanding where we have actually the agility for exploration and for making the largest changes with the minimum cost but maximum impact. So in this case, in the very early stage of design, where it's very easy to iterate on designs, it's very completely inexpensive. It has actually almost zero impact on the cost. This is the moment where the most impactful environmental design decisions can happen and the most impactful optimization can happen. However, what we see in practice when an environmental report is also part of the delivery is this aspect of continuous iteration on the design, on the concept design, that is very detached from the development and delivery of the environmental report. Therefore, it's often that we see end results of the environmental reports that arrive too late to be considered and impactful in the design process. So what we work towards really is enabling this rapid iteration with environmental data, so that the environmental report is always aligned with the design and has already informed all the iterations and the versions of the design. So what we have set out to do is to make climate simulations accessible, and moreover, to support you with all the tools necessary integrated in your workflows seamlessly to enable designers to achieve sustainable designs based on data and with the right kind of insights obtained in real time as you design. So I told the story of how Infrared City came to be, and this is exactly what we were looking at. We were looking at the need to apply computational fluid dynamics simulation, so to understand wind impact in and around our designs. That is a long time kind of desire to increase the application of this simulation and to increase the way in which this simulation impacts our iteration. However, one of these simulations is a very time-consuming process for anyone who's tried it. You will know that there is quite a long process of preparing the geometry, creating all the right setup for the simulation, then the simulation itself takes a number of hours to process. And of course, in order to be able to use this data in any meaningful way, you also have a relatively long post-processing time to extract visual or raw data that can be useful. All of this, depending on the size and scale of the project, might cost a few €1,000, require one expert, and take a number of days to produce. With Infrared City, we can do this in 1 second. the dollar cost of it is actually even much less than what is shown here. The way in which this is meaningful is by enabling the non-experts, the designers, to have access to the post-processed data that is ready for generating insights, without having to wait on or without having to sacrifice the need for simulation for only for high-end, very important projects. Of course, with this reduction in time, there is also an impact on the accuracy. However, as you can see, generally the patterns are well enough predicted by the AI simulation models with sufficient accuracy to enable you to iterate and, of course, arrive to a final selection of designs that can be fully tested with physics-driven simulations. Now, how we achieve this is basically by training our own surrogate AI models based on thousands of simulations that have been run in the physics analytical way with data and geometry that is coming from hundreds of cities and augmented with further with synthetic geometries in order to capture as much as possible of the variety of not only the existing state of the urban morphologies, but also whatever new designs may throw at it. And by doing this process, we are essentially pre-loading, using this computational time so that you can have access to the end result without waiting for the simulation to be performed. So this is the power really of AI models that are able to predict patterns really well, and we've all came to understand how this is actually one of their top characteristics, the ability to predict patterns. So right now we have a platform that is able to simulate wind speed, wind comfort. It's able to simulate thermal comfort, and very soon we will also have available the solar access, so that the direct sun hours as well as the solar radiation. We are continuously developing, continuously expanding the number of simulations, also going to different scales and understanding how different scales affect each other. So how to take indicators from simulations run at different scales, all with the goal of arriving to a more global understanding of a climate resilience index, be it for the larger scope of a city, or for even the smaller development of a building or of a master plan. Now, as I said, one of the barriers that we were trying to overcome is the aspect of integration. So for this, we are proposing an open integration approach in which our core simulations and AI models are available through a series of contexts, through a series of ways. On one hand, we have a cloud app where you get the most fully featured experience with a lot of additional support features and so on. We also have developed CAD and BIM plugins to enable you to send geometries, run simulations, and access the results directly from your work environment. And of course, all the data will be synchronized to the cloud, meaning that you can then access it back through the cloud app as well. And we also have an open API integration that is available for and can support building more customized platforms to tackle a very specific problem that you may have. So we are working to on one hand, make environmental simulations faster and actually real time, so that you get the results exactly at the moment that you need them. But on the other hand, we are also working very hard on the aspect of intuitive results. So creating insights rather than simply visually represented simulation results is what we are working towards, and we are doing this through AI agents that have access to all of the information, that are able to make inferences and judgments regarding the design. They are able to even make recommendations for future improvements or future iterations. So with this, I will go to the website to show you how you can sign up for an account, and also to take you through a live demo, a quick live demo. So pressing login, register, or try now button on our webpage will take you to a login page where you can very easily get a trial account. We have 14-day trials available today, and once you do, you will be sent to our web app page that will feature this demo project on your account. I will take you through the demo project in a minute. For the moment, I would like to create a new project. And here you can search for any location in the world, and you can also make any necessary changes. I have mapped one of the locations where we could work in here. So you can set up a project by simply putting in a location. Then if you need to make any adjustment to this, you can adjust the location, and as you will see, the geometry of the project will be automatically loaded and created on the project. You will get a view of the analyses that are available. And we'll be able to set up a site for your project. This will be useful in computing KPIs and understanding how the site performs. And you can also enable the loading of vegetation directly. So while the project is being set up, a few connections are happening. You get the three-dimensional model of the city, as well as we match the closest weather files. So the closest typical meteorological year. This is a file that essentially describes the weather conditions over a year in a location. If you're working on a more specific use case, you have the ability to upload your own weather file. So if we could be talking, for example, of a predictive weather, so where you want to simulate for the year 2050, for example, you have the ability to upload your own file here, and you will find some information, some description of the project location, the site information, and on the right hand side, you have a number of important kind of utility features. You can have full understandable visualizations of the climate on the climate dashboard. So this is reading the typical meteorological year file that it has extracted, or that the user has uploaded, and you are able to see the graphs regarding the solar paths, the values of radiation, sky coverage in relation to radiation, as well as temperature, humidity metrics, comfort metrics, and of course wind metrics. All of this available for different filtering, so you can see a particular month or a particular season, or you can have the full annual display. This is very helpful for speeding up time. I know that in most offices there is a way to extract this weather graphs. However, with Infrared City, you have this available in essentially no time, in a standardized way and in a very interactive way that allows you to share it with all the designers and understand the weather results or the weather patterns in the city. And then the main element, the main feature of our application is this simulation workflow, which allows you to very simply add any of the existing simulations with minimal parameters that are necessary. So in this case, you can test wind speed for any given direction as well as any input speed. We can add this simulation, and you can add as many simulations as you want here, up to a number of 30 or so. So you are not limited to run simulations one by one. The ideal way would be to create a simulation scenario that you can then continue to use throughout your iteration. You can also understand pedestrian wind comfort. So this is essentially connected to this weather file, to the typical meteorological year, gathering data about the wind distribution, both in terms of directions and in terms of speeds. And then it's enabling you to understand how a full year or how a particular season would look like in terms of comfort based on different comfort criteria that are standard, and you can understand more about how they are formed. So we can see, for example, winter comfort in New York City in the early morning hours when people are commuting to work. And we can also add thermal comfort and look at the very typically hot season for the afternoons, where you would want to have some level of interaction on the streets. And we can also get a thermal comfort statistics. This is looking for the percentage of time where a part of the site is under thermal comfort, so between 9 and 26 degrees in cold stress or in heat stress. So in this case, let's see cold stress in winter in the morning. And once we set up all the simulations, we can now run them all. You will see some simulations will be extremely fast. We're talking about the wind speed in particular here. Some of the others will take a bit longer computational time. However, everything will range in a matter of seconds, maybe up to 20 seconds or so, for the more intensive computations. So the pedestrian wind speed essentially has computed a number of different wind speed scenarios and has aggregated the data according to the Lawson's criteria. And then the thermal comfort index, thermal comfort statistics are actually a combination of AI models as well as physics computing the availability of sun directly for the location. And as soon as all the simulations have finished running, you will see that we have a very useful graph that is showing the distribution of values. Another important thing to say is the fact that the thermal comfort simulations will take into account the trees that are available on the site, and this is actually causing a bit of an extra time on this thermal comfort index simulation. So in the meantime, we can talk about the other options that you have. And on the right side, you have options for editing the existing contexts or the existing buildings. So in this case, we may want to delete this building. I will just refresh the simulation, as sometimes this can happen. So once we go to the results, is that the results have actually computed. So you have the ability now to edit some of these buildings. So for example, we can remove one of these buildings over here and add a new building model. Um, So I will look at this to show you all of the options. So you have the option to place the position of the new model on the site. And what you will see is that this model has been saved with the flipped axis, but you have the ability to rotate the object's axis, which will position it correctly. So then we accept, and then using the other controls, the normal edit controls, you will have the ability to position the object on the site according to your needs. I will now run again only the wind speed simulation, just for the interest of time, but you can now run all of the simulations again and see how the results have changed between one and another. So now you can see that this simulation has been adapted, and the new building is showing in the simulation results. No, the question comes how you can actually understand the impact that you're having throughout the different iterations. And for this, I will go to the demo project. So one of the other projects that have a number of different iterations run. And I will start by removing some of this vegetation here, just to make enough space for a building model. So then we can add a new building. I have another one here. I think this should be fine. Yeah, this should be fine. And hope it will fit. Okay. This is actually quite a big model, but we can position it here to see how it would change the KPIs. And once you do this, you can run the simulations again. Again, here we have a number of simulations. You can run all of the simulations again and use the save snapshot component. I will, in this case, again, in the interest of time, run only one simulation to see how the model adapts the wind patterns. And in order to save the design option or the snapshot, you would need to run all of the simulations. So this will force running all the available simulations. However, we already have saved a number of design options here. Once a design option is saved, this key performance indicators are automatically computed for each of the simulations that were run, allowing you to essentially rank all the different design options according to parameters that are most important to you. So, for example, we want to ensure that we have the highest amount of ventilated area, So we will select the option that from here that has that achieves the highest number, and we will see that this is the option 4, that is a tower. So this allows us to go into a comparison mode where you can see the selected option as well as another tower option, and understand how the results are different from each other. So this is saving the simulations that were already run. It's not rerunning the simulations. And you can see how the two designs um, perform compared to each other. So we can check the shading or understand the reality of the situation on the site versus on the total area, as well as evaluate a range of temperatures that are available on the site. Now, with all of the information, you also have access to a reports generation mode where you can set up a new report very easily by selecting one of the scenarios to be the main scenario, as well as all the different design options that you want to show, and you can generate a full report. This will take a few minutes because it's actually gathering all of the informations from the project, as well as sending them to a number of AI agents with expertise or trained with knowledge on environmental and climate policy, as well as scientific papers and so on. And it's making insights, is generating insights on your design. Furthermore, this report is presented in this split view with half of the screen available for an interactive display where you can actually see the design and the simulations in full 3D mode. As a user, you have the ability to edit any of these gray fields, as well as run, edit, and rerun all of the AI summaries. So where you see this button, this will be generated with AI. You can see that it's actually looking at the not only kind of understanding information about the location, but actually looking at the number of buildings on the site that are visible, and giving you the information about this, as well as some minimal information about the weather, about the climate. You can have a lot more information there, where you can also show all the climate graphs. So all of this information can be then available for you to share with your client, with your other team members who don't have access to infrared CT, or with anyone you wish, really. One more thing to say is that the AI responses can be edited. So if you wish to check the results and make adjustments, you can do so. If you want to generate again, you can always click the generate button again. But the most important aspect of this report is that it captures all of the design options that you selected with all of the simulation results. So we can see, for example, the pedestrian wind comfort and the impact of the pedestrian wind comfort of this tower on the pedestrian wind comfort, or the impact on the different thermal comfort simulations that you have run. You can also check the other simulations, and for all of them you can generate with AI an interpretation of both the design and the results. This will take us some time, but I can start the generation. You will see that it cycles through all the information, and it will then be able to add a summary to this report. And in the meantime, while this generates, I want to also take you through to our connector, and I will not present everything, but we do have a Grasshopper connector that will enable you to do some very interesting workflows. On one hand, it enables you to design in real time and get the simulations automatically. But even further than that, it allows you to get the simulation results in raw format, so to get the raw data directly in your Grasshopper definition, so that you can do any further work on it. I will again from here load the latest project that we worked on. And you will see that you get immediately the you get immediately all the context information on your Grasshopper definition. You can keep it, delete it, bake it, and make modifications. You also get the vegetation separately and the analysis configuration, which allows you to then update the project in any way that you need. So I can potentially just add another building in here. I could add another building, merge it to the existing buildings that I have, and send it to the project, which will enable us to see the project updated in the web site. I will load it in a few minutes, but I also want to show you how you can actually run an analysis by going to the simulation mode. You can select from here. I will select only the the wind speed analysis. So we'll select only the wind speed analysis to make it faster to run. However, you can run all the analysis at the same time. You can click run here and you will have notification that the analysis is starting, and then it's completed. You will be able to see the results using this component. And you have the mesh results, the data, as well as the KPIs available directly in Revit. Sorry, in Rhino in this case, and also in Revit, which is pending the launch. It's at the moment in restricted access. So if we go now back to the report, we should already have on the other project, we should already have the results of the AI interpretation of the simulation of the solution, of the design solution, complete with a number of strategies recommendation, which can be very, very interesting to go through. And you have the ability to publish this report and share it online, or share it with specific members of the team. You can also download this report as a markdown format, which enables you to access to have all of the screenshots from the projects, as well as the graphs and the text. And if we now go to the project that we just updated through Grasshopper, you should see that this is available here. I think this would be it. I have to there we go. So you can see that the very badly added cube or box is now here, as well as the simulation that has already been run in Grasshopper is accessible through here. And this is essentially what Infrared City platform is today. It is a platform for your agile design, for your agile sustainable design, particularly for block level, so new buildings and master plans at the earliest stages of design. We are expanding this solution, and you will see some very interesting updates in the coming months. But I will leave this for another day.
Thank you. Mulțumesc. Yeah, I mean,
Thank
we've
you.
got a few questions coming in, and I just want to make a comment, initial comment, and that is that I think what you're doing with these, I see them as surrogate models, is that you are really speeding up the design process. This is not an accurate model, but it's enough to give you a sense of where you can go. And actually, from my book, the recent second edition, the yellow one of my book, one of the, I mean, I had three offices that I looked at: Foster and Partners, Zahedid Architects, and Corp Immobilier, and Foster and Partners took a very different view. I mean, the other two were kind of using AI to generate images and things and designs. Based on their own data set. And they said, we don't need to design. What we need this tool for is to speed up the process. And that, I think, is, I mean, in general terms, that's what the research that was done. I mean, it's over a year ago now, in fact, more than that, at Harvard and MIT, looking at the impact of ChatGPT. It sped things up by 25%, and as the tools got better, and it has got much better, that percentage is going to increase significantly. And I think that is almost the most important thing to bear in mind is the speed. And frankly, I think that's where it's going to have the biggest impact is on speeding things up. And I mean, given the fact that buildings take so long anyway, I mean, it's unbelievably how slow they are. If you could just speed things up, and in fact, XCool, who are going to coming on next, who once managed to design and construct some hotels during COVID. It was an emergency, so it was done very quickly, but they did it in 16 weeks. And when you start thinking about that, I mean, we in England we say time equals money, and it does. If you're a hotel owner, the days that you're not renting out your rooms are lost revenues. So I still think that's going to be a huge impact in terms of how AI is going to really influence the workings of an office. But I
Definitely.
had, yeah, go
Yeah.
ahead. Yeah,
I think one of the aspects to also consider is this as a result of speeding up, right? What we actually end up with is increasing the output. If you really consider it down to the end, and then a very important aspect, particularly in the situation in which buildings and construction actually impact so much in the current climate situation and the way that the rate of change is to consider the quality of this output. Because reducing speed and an increased output in that is not going in a well adapted kind of sustainable direction can actually be quite detrimental. So we are also working at the same time as reducing the time necessary. We're also working to enable an output that goes in the more at least data informed direction, right? We still have to see a lot about adaptation and resilience. And this is something that we can measure only with hindsight rather, but at least we will be able to see a lot of improved data and improved awareness of the design suitability.
yeah. I mean, just one comment I had is when you were, I mean, I was really transfixed by those. You had these dancing buildings, which weren't necessarily dancing, but you were showing how you could change them and mutate them and things, and and they literally were dancing across the site. But my point was this: is when will you are you going to get to the point where you're going to generate optimized solutions, or is it just simply you can see what they are? But I mean, would is that going to be part of the thing? And the other question I'd have is that if you do have these optimized solutions, can you in a very obvious way show us what are the savings in terms of energy consumption or whatever else, is data that is on the screen? Is that something that maybe you got to get towards? Because I just think that to spell it out is kind of
Yeah.
hugely significant.
Yeah, definitely. So these are like two parts of the question. On one hand, we are aiming to bring these recommendations from the level of text right now to maybe more meaningful, immediate design changes that are possible. However, we always see the designer as leading the process. So this is one of the balances that we have to find and strike. I personally am not at this point in time of the opinion that we need to outsource design fully, but rather to have an augmented way of arriving to the right solution. Opinions can change at this point, so I think we're still in an era of discovery. And regarding the showing the data, the actually meaningful impact immediately on the screen, this is exactly what we are trying to arrive. So I mentioned a few upcoming features, and this is where the features are going, kind of translating the simulation results into really actionable data that can be showed as one number or a few numbers that can be guiding the project.
Because I mean, the comparison I'd like to make is that there was a guy, and I forget his name, but he was from the UK. He did a PhD on AI and yacht design. Went to go and work for the America's Cup. Then he worked for commercial shipping. And what was interesting is that they developed this technique for a kind of sail. Actually, it was amazing. And he literally said to the client, "So we can reduce your carbon footprint by 20 to 30% by doing this."
Yeah.
And I think that's the kind of thing to put it up front to the client, say, "We can do this that will
Yeah.
make your offering so much more powerful, so much more powerful."
Indeed, indeed.
We've got a couple more questions. Wanyu is ready to present in a moment, but let me just go for these questions. And there's one, the two in the chat. One in the chat's from Barak, who's in Turkey. Are these simulations and statistics countable for all parts of the world, or are they compromised by the level of data sharing of local authorities? Yeah, good question.
Um, in reality, our simulations are available globally. Now, there is a caveat regarding the amount of data that is already publicly available. You've seen, for example, the context generation in New York was quite highly detailed. In some parts of the world, this may not really be the case. We do have, however, support and tools to allow the user to bring in their data. So it's very um, common that a designer will have the context data, the very detailed context geometries available. It's also very possible that they would have the weather file available for the location, and we can allow the user to upload this. However, we currently have I wouldn't say 100% global coverage, but 99% global coverage with different levels of data availability, of course, and data accuracy, and I mean the context related data.
We've got two more questions. I think maybe Mitra, did you ask one of these questions? Maybe you would like to ask it. Mitra's been live streaming. Hi, Mitra.
Hello, hi. Thank you so
Hello.
much for your amazing presentation, and it was so comprehensive, and we learned a lot. My question is, since it's a kind of, as far as I learned from your platform, we can somehow integrate it with any other spatial analysis, isn't it?
You can you can connect it with other analysis that you achieve through other platforms, as long as these are available in one of the same um, softwares that we have connectors.
So can Inferencity output somehow connected the features that like to urban configurations metrics such as connectivity, centrality, or enclosure in space syntax? Would it be possible to integrate or get data from it as well?
Yes, exactly. So if you use our platform through Grasshopper, for example, where you also have a lot of this analysis available, you will have the possibility to connect the data directly that is coming from our analysis to the data that you get from the other analysis. Also, this is arriving at this more urban scale indicators is also a future utility that we are bringing into the platform as well. So this is one of the direction in which we are going.
And could you please explain that what kind of datas, what kind of datas the AI was trained, and are these 3D models or 3D heat maps or sensor measurements?
The wind model was trained on actual CFD simulations running using the standard kind of industry relevant method. These are CFD simulations that actually run the physics computation to predict wind in a three-dimensional model based on geometries, based on context that is both coming from real world data and enhanced with synthetic data to ensure that we obtain enough volume. And the model or the simulations were used in a way to enable the model to predict planar results. So this is the wind model. The thermal comfort models are actually quite a lot more complex because this is where you see a lot of the weather data, a lot of the climate data impact the results, not only the geometry. So for the wind model, we have the simplicity of having only the geometry really impact the results. But for the thermal comfort, there is a lot of the temperature, the heat, the wind, all of this impact the results, which means that we are actually training the models based on specific data and to kind of arrive at the existing kind of industry standard formulas. And we are also complementing it with a physics, with a high-speed physics simulation to arrive to the end result.
Thank you so much. I'm so excited to use it, and since I've already worked on space syntax and urban morphology, I'm very excited. Also, I had one more question regarding the corrections method. For example, do you use any corrections method if the predictions are slightly off, or
So at the moment, our models are not taking, not retroalimented, retro using feedback. They have been trained, validated, and are now used by the users. So in this sense, there is no correction method per se that is available now for the user. All the correction has happened in the model training phase, where indeed the model is able to learn from mistakes. This is where we learn from generally.
thank you so much.
Great. Mulțumesc. Well, that was fantastic. We now have Wan Yuhe, Dr. Wan Yuhe, I should say. She now has a doctorate design from FIU. Wan Yu is actually one of the most significant people in the history of AI and architecture. She wrote the first book on AI and architecture. I wrote, I guess, what's called, you say, is the first mainstream book in English on the topic. But Wan Yu was one of the early pioneers, and several years before my book, she wrote her book, in fact, two books. And XCool is the company that she set up. XCool means ex Coolhouse. She was working for OMA for several years and was quite frustrated by the inefficiencies in the office. And that led to a project to try and use AI to improve. Wanyu, it's great to have you here. And welcome, welcome. You're muted, I think. You're muted.
Can you hear me now?
Yes.
Is it
Yes.
working? All right. Okay, great. Okay. Thank you, Neil. It was a pleasure. Let me share my screen. And I think there are things happening quite fast. And I made one of my presentation, like this presentation, the base was 2 years ago or 3 years ago. And I keep changing it. If you track back to the history of the digital futures that we talked about, AI software for the office, my presentation is always changing. I mean, keep updating because there's a lot of things happening. So I would like to start with the map. First of all, we understand that the map booklet, for instance, in the 90s, it cost like $10 USD, and then in like a little bit later or in the same time almost, there's a digital map coming in. So before the internet coming in, there's a domination of the traditional way that information exchanges, that's offline. And after internet coming in, then we have all the data be uploaded to the internet. And that is the base for today's cloud and the data sets. But the most important thing is the price of using such data dropped like 1,000 times. And this is a significant change that when a, let's say, a function or a tool or a capability, the cost of it be reduced 1,000 times, it means there is a big change, and it's or we can call it a paradigm shift. And today we are facing such thing. It's not just happening in large language model, but I take this one as the one of the example. So back in 2019, actually this is just 6 years ago, when you want to do a chatbot, usually it's like to B to business, it costs you like 20,000 US dollars. But right now, with ChatGPT and all other large language models, it's 20 US dollar per month. And what is this thing happening? Is the new paradigm shift that AI models representing the knowledge is already everywhere. This is a diagram shared by Dr. Lu Qi, and this is a very inspiring diagram. We have a kind of a replicated and try to understand it better from our perspective. So starting from the 90s, all the human things gonna be changed and gradually translating or transforming into the machine. So first is the information as the map I showed earlier as the example, that information become online and data start to accumulating. And when like already 30 years later, the data accumulate to a certain level, and we have much higher calculational power and much better algorithms. Then the model came out, the AI models. There's a different models, the language model, image model, video model. Today, there's also other models like 3D model, even other types. And all those models, it give us another level of intelligence, that machine is not just taking the information, but it's taking the model, which is the pattern, the knowledge behind it. And in the near coming future, that we can see is this is as one of the third rights for human, which is the action, will also be taken by the machine. Or this taken means machine start to learn it and become better than us. So this is how the history is undergoing. And the key is, as a kind of a conventional discipline like architecture or urban design or so on, how can we survive in this new era and even for the future? So this is something in front of us. And for myself, I have noticed quite a while ago, because if we see the trend of this now called AI or earlier called machine learning, artificial intelligence, this kind of a notion starts in 1956. And besides that, knowing those histories or learning those histories, I was a sci-fi writer for my free time. So I'm a kind of quite into the notion of artificial intelligence since I was much younger. So I keep tracking on what's happening on this side of AI, and we can see the today we call the neural network was raised in 1980s, and this kind of new um, AI, like say architecture or structure of the models, it become more and more mature. And after 2010, which is the Fifi Lee started this ImageNet competition, and there's Alex led, which is a work with Alex and uh, Hinton and the CTO of or chief scientist of OpenAI. And those guys, they started to using large quantity of data to train the model. First of all, it's the image, and then they find, wow, this is a really useful to use neural networks to train the model, and the output is become more and more accuracy and more close to what we want. And after that, now already 15 years, and we can see there's a more and more big models, and the data become bigger and bigger and more mature. Even today, we can see some, in some ways, the large language model, or we call this AI, is already much smarter than us because they have a much broader knowledge. So in this way, we already found back to 2023 a lot of enterprise and companies start to incorporate or embrace AI into their sectors. So they become the marketing, content AI, the video AI, coding AI, and image AI, of course. And even for the venture capitals, they start to foreseeing or to try to guess what's the future gonna be. So back in, I think this is in 2023, Sequoia, they have this chat showing that the image model become mature by 2025. Nowadays we can see, yeah, totally. And for text, it's back to 2023. We can see yes, and they become more and more mature. But for the 3D, which is more related to our work as architects or designers, how about those ones? Actually, I think this prediction doesn't really predict it what this kind of 3D we need, because what we need is a higher dimension file models, which means it's not just the 3D they are talking about today. If you notice, the Fifi launched one of her model that with the text you can generate a video, and this video is a kind of called a world model. It's representing a 3D space by video, but what behind it is it's more like a image composed space or wrapped environment, and this type of thing cannot really work for us as a professionals, because what we need is a precise vectors and precise dimensions with all the geometry informations. So this is something it's not there yet. Why is that? If we look back to what we are working with, it's starting with paper, of course, for drawings, and then be described by ISO. There's a different levels of information or format, let's say. So the level 1, which is already digitalized, is the CAD in our history, in our field. And in other fields can be scanned image or scanned PDFs and so on. And the level 2, projecting our discipline, could be the CAD drawings, which is called a machine readable document. It can be processed by software. So this is how we call software. But I also suggest something for Neil. Maybe next time we can change the name of software for this topic, because nowadays it's not just software anymore. It's quite different thing now. Because after that, let's say if we talk about level 3, which is a machine readable content, for instance, the beam, which we understand it's a kind of a content with multiple standards for a given purpose, and also the semantics enhancement or enrichment for the content for selective access. So meaning it's not just the geometries as the CAD provides us, but also it contains the data or some of semantics that we key in for this model. So it carrying not just the geometry anymore, but with data. But this is not the stopping or not the end. The ultimate answer to a format that could work for most of the industries is this one called machine interpretable content. It's kind of a new metadata. It's not there yet before ISO described this kind of standards. The key of it is it contains the self-learning analysis and the validation cycle to improve content, meaning it's not just the data model, but it contains the pattern. Pattern means the AI part of automation for questioning, answering, or predictive content supply, and so on. So this is how the future format it could be. And nowadays we see, we call it agent, right? There's a lot of agents become more and more popular and mature in different vertical industries. So the notion of software become more and more blurred in this or under this kind of format or based on this format, because with this format it's not just the software anymore. It's kind of an agent or kind of a co-pioneer or assistant that can work in several procedures or workflow for you. It's not just with you or not just by you. So it's quite different notion since then. And what we are doing as Xco, we noticed that the level 2 CAT and the level 3 BEAM for our field, or with, let's say, machine readable document or machine readable content, it cannot really work for us because I believe most of you understand that you're using BEAM, it requires everyone in the team using BEAM, and also you have to check for each of the different disciplines. And the most important thing is you are building this model. And this model is so complicated. It not just contains the geometry, also contains all the information data you have to key in correctly. So once you change something, you have to change it for everyone. And this is something I don't think it's a right way to do. If we're back to the key, or let's say the first principle, how we should represent the idea of architecture and to be built. The drawings are not really necessary if we think the entire industry as a automated production line. So the design, why we have these drawings? Because designers need to represent their ideas and need to exchange knowledge by different disciplines, as well as for the client, as well as for the municipality, as well as for the users, and so on. So we need drawings to show how we think. But if the key partner or the co-pioneer, the co-pilot is AI, do we really need drawings to show the ideas? Or do we need this format of drawings to show our ideas? This is a really question mark. And this is something an essential question for Xcode. We don't think stages in between are really necessary. Of course, right now everyone's using CAD, everyone's using BIM, so you have to connect with them and exchange information or data with them. However, we don't think this procedure is that necessary. That's why we have invented our own format. We call it a data-driven model or mode, and then we name it as the AI-driven BIM on cloud, ABC. It's kind of a building information model, but it's not the BIM that we're talking about today, because this BIM is be generated by AI, and everything is running on the cloud. And the key of it is including the data, the geometry, as well as the pattern, which is the most important part, including the compliance, logic, rules, and so on. So everything we are building this format, it's based on the future, how we gonna work with the entire, let's say, with the entire supply chain or the workflow. So if we look into our current workflow, we can see there's quite a lot of different softwares we're using. And of course, for the near future, we're still using softwares. And those softwares might be kind of replaced or combined with AI. So there will be some AI integrate softwares. But eventually, there will be just the one agent that can go through most of the workflows. Because when we're looking into our workflow of architecture, it's very complicated, but it's also very simple. The simple thing is there's only three parts of it. First is understanding the requirements. And this part can be resolved quite good by large language models, because our requirements mostly, for instance, from the client, the needs or the objectives, constraints, and so on, all those things are text-based. So those kind of things can be integrated with large language model. Of course, there's some visioning that need to be showed and integrate with the client. Those things can also be resolved by today's image models. So the second part is I think it's the most important, which is discovering the possibilities. After understanding the requirements, the needs, and the compliance, and so on, we need to find out what's the best solution and what's the best possibilities. The best is a very subjective thing. The best may mean for the client lower cost. The best may mean different for the user. Maybe it's the better sustainable concept and performance, and so on. So, what is the best option we can find out? Currently, we are, as architect, trying to balance this kind of different demands among different sectors or factors together, and to show to the client and round again with different options. But this doesn't really sustain, because as human being we have very limited time and the skill sets and the representation methodologies and so on. So there's several gaps in between our workflows. I think I have mentioned this also in my previous other presentation or talks. The first is between the client and the designer, because we have the mad chasm. We need to cross this chasm to understand each other. But another thing is your brain and your hand. There's also a gap. You have to fulfill it. And then is the compliance. You have to match with the compliance. If you are international architect, you work in all different countries, how you understand the different culture, different regulation, and so on. And the next, there's also gap between the geometry and the data, meaning it's the gap between the value engineering, the cost, towards your design. And in the end, when you go to the site, the construction, currently most of the constructions are manually. So there's a lot of manual errors and manual limitations that will prevent you to realize your design. So you have to change a lot of things to make it work on site. So those gaps are the things we need to figure out. Actually, we should figure out in the beginning. However, those are be sequenced or became like waterfall type of workflow because of our skill sets and because of our softwares. So in this way, back to the previous question, how should we work in the future? I don't think we should work with all those different tools. I don't know your experience, but myself, I have a kind of really spent time to learn some of the softwares in the early pages and to really use it daily and train myself to be more and more, let's say, quick to use those, more effective to do all the outputs. But this is I don't think it's really necessary in the future, because the key, we need to understand what is the key of architects in the future. We will talk through by some of the examples, but I do think the key is our design thinking, is the thinking. And that is the most important thing. And all those tools will become one single agent in the future. And it will cross all the gaps, because in the beginning, it will consider all the demands, will consider all the compliance, will consider all the cost issues, and will consider how to realize in the factory or so on. So those won't be an issue anymore. And then the output is a kind of a very easy thing after this, because output is kind of exporting the informations out from what we're having. So in this way, I will show a few of the options. So first of all, I will show what we are setting up today to reach to a set that the AI agent can help us. So first of all is the AI design part, which is the covering the master planning, building design, and interior. One thing is we started with the residential typologies, not everything. So residential typologies for us meaning the apartments, villas, hotels, dormitories, and so on. Those type of things are the kind of most demanding in the market. And meanwhile, you have most of the data from those sectors. So we started with those, and you may know that we started in 2016, and with a large data be supported by our clients, our collaborators, and we kind of trained our own models for the different sectors, and can covering right now for the master plan, building, and the interior design. In my last year presentation, I will chop those three and chop the way how we work through the AI. But today I'm gonna show something different. Sorry, let me share my screen. If I may, I just close the video. It's easier. Can you see my screen now? I think it should be all right. So this is something new on our LookX AI. If you use the LookX, you may know previously we were focused on image generation, like image to image, text to image, or real time, or if you can draw your things, or then generate videos, and so on. But today we have a newly launched this chat generation, meaning it's a AI agent based. So you just talk to it, and it will give you the workflow that you need to click each of step to do your outputs. This thing has already been launched for a couple of months. I think I just show one of the examples I did before. So this is a real project that we are discussing with the one of our Saudi client. And first of all, we gave them the style, just keying what I want to do. And then I use this AI generated image and for the style. And then I input this photo took on site, and it generates this outcome, which is the combination of the style and the real condition. But everything is based on the chatbot. It's not like the previous way I have to, for instance, if you can see this one, text to image, you have to upload everything and click and set up a lot of data and so on. So it become quite different to the previous models. It become more and more simple and easier. And that is the key that AI agent can support. If I may back to the presentation. So this is something, of course, those are big enterprises like Google or OpenAI, they are doing similar thing, but we're confident in our own data sets that we train better with our architecture, urban design, and interior design data sets and get a much better quality. And I think beyond that is what we are setting up is this level for machine interpretable content. Image and videos is just one thing. The key is how we can go beyond. So we started with image generation, of course, but meanwhile, as Xcool, we started the geometry and 3D model generation in the beginning. For instance, in the master plan scale, integrate with the urban, and we also tried how to set up those envelopes with AI and generate abstract 3D models. But those abstract 3D models can be somehow transformed into our format. It somehow is something that we did for the Xcool Design Cloud, as you can see here. You key in your information and we generate options for you, not just one, but thousands of options. And all those things are pre-trained by the relevant data sets and to get the best option out from those. So this is the scale of the master plan, as well as for the building itself. And now we are entering to the let's say interior or more in detailed phases. So I will walk through some of our working samples. Because of time constraint, I think I would just jump a little bit quicker. So first of all, those generations we are using are combining with the spatial models and then apply to different real cases. And it will help us to refine or to fine-tune the model better and better. Those are all the projects if you see the years in the past, as well as this is one of the project that we did quite a long time ago before Xcool established. We're using algorithms to generate the design and then do the simulations and let's say the improvement and the optimization. And you can see this is the design. Eventually, this is for a concept stage. The red ones means the higher density area, and the blue ones are lower density area. And eventually we got this part of the work, which is a phase 2, which is this one, and the entire is exactly like what has been predicted. See, there are the higher density ones, and we are doing this part, and it has been built exactly like the design. So this is how it looks today. So if you visit China, you can come here. This is in Shenzhen Bay Area. It's one of the high-tech park, and very very famous, and next to most of the famous companies in China, like the Tencent and so on. So this is we consider this one as the one of the early example that has been done by AI. And second, or machine learning, let's say, is not exactly the AI notion we're talking about today for large language models or those deep models. But then this is how we started. And then we extend those kind of experience and our technologies into the residential typology. The previous one was a tech park, meaning mostly are the offices, some commercials, and some apartments. And then we focus on the apartments and the villas, these typologies. I will jump a bit fast. And the key for this one is we're using modular system to do it. So if you check this one, you will see those are the modules that we are using to compose the design. And the modules we are talking about is the modular, the 3D volumetric modules. This is as one of our latest working sample that we did in Abu Dhabi with AI generated option. And it's not just the 3D geometry, it's including the strategy of using modular system and all the simulation for physical performance, as well as for those videos, images, and so on. And talking about the modular, what we're talking about is this 3D volumetric. You can build 80-90% in a factory. This why we're using this type of ways, because in 2009, actually 2021, yeah, we are working with one of the very interesting project, which is a hotel by modular system, because we have into this particular typology since 2019. Why is this? Because I believe AI need to connect with the manufacturing to support us from design to manufacturing with DFMA, design for manufacturing and assembly, for some of the typologies. So the steel modular and the concrete modular are the ones we are focused on for the residential typologies. And with those typologies, go through the entire planning, design, manufacturing, assembly. We finally finished this hotel project in a very short time, so 4 months. And this is an incredible time compared to a conventional way. The time means efficiency. Efficiency here, not just the design, but also for the procurement, for the manufacturing, and for the on-site assembly, meaning the construction part. So everything here you can see are overlap, and the key is our ABC, this kind of model, and with the components library is supporting the entire thing to be compliant, to be really realized. And one more thing for that is this format can also integrate with the machines. As you may know, that China invents a lot of these construction machines, and this is one of our sister companies' work. They have more than 28 types of construction robots, and those robots, you can also use our ABC model, which is machine interpretable content for the site, and that is something can support us not just in the factory but also on site. And this is how we think the future can gonna be or gonna look like. So it's also, this one is from the one of the McKinsey report for the future construction, but we have added our own understanding on it. First of all is we think the paradigm shift is not just in one sector, it's in the entire workflow. So projects won't be parallel to each other, and in each of the sector we are repeating the same work, but not sharing the value, the knowledge, the uh, efficiency, and so on among those different projects, because each projects are so unique, because each plot is unique. This is how we work today. But in the future, or currently happening, is that we're using AI and manufacturing all together with this DFMA methodology, and then we can create a kind of a center that applies all the uh, different projects with standard components. This is just like Legos. Legos are standard, but you can compose for uh, millions of different options. And this is how AI can be used here or play a role here, is to balance the standardization and customization, and then those works can go through to the site with, as mentioned, with the robots and the construction team. So the final case is that this is one of the museum projects that we are working. And the background of this project is in the middle of China, in between the mountains and mountains and the base location, and and in this kind of a location, we can see how the different let's say the landscape and the topographies and the urban tissues. And with all those solutions, sorry. Sorry. Wait a second. And with all those solutions, and there's a issue to be found is in this particular site, we need to prevent the biological habitat, and also to make it more user friendly for the human habitations. So the position for us is to integrate the nature and the human society. And in this way, our argument is become very simple. It's a kind of integration with the mountain and the river on the site. Is not like a very dominant and very strong configuration that caught the mountain and the river connections. So the building become quite secondary for the site. So this is what's the argument for this, and then is how to realize this idea or this design concept. So the AI helps here to generate different options and meanwhile to simulate different options. And with all those simulations, we find out that these kind of layouts can help us to get a better environmental performance in terms of its microenvironment, the temperature, the ventilation, and biological accessibility, and so on. So eventually, with the multiple optimizations, we finalize form and get this final result. It looks quite good in terms of its become like a quite integration with the site and with the idea. And this is how it looks. Of course, there are some massing. You can see the massing there because we have a GFA, of course. But for the later stages, there's also something we have used for optimization, which is to generate a new facade to replace what it had for more than 30,000 different triangular tiles, and reduced it to 12 types of it. And this is a significantly drop the cost as well as the complexity of the manufacturing and the construction. And this is how it looks be done. It's quite gloomy in the Sichuan region. This is a real photo, by the way. So it has been changed a little bit because you can see one of the pavilion has been cancelled because we want to smaller the size of it. And as a conclusion, I want to share with everyone is I do believe that AI, of course, will take a lot of the manual works, but that's called manual works. It cannot replace the thinking works. Even you are working with AI today, for instance, ChatGPT or so on, you need to ask the question. And the question is the most important, not the answer by AI. So how we can formalize a really good question, this is the most important thing. And I believe this is the key strength of a human being. Because as we can see in the workflow, find the issue, find our positioning, find our argument, and provide solution. This is what men are more, let's say, good at. And from the solution on the scenario schemes, preparation, the representation, or even the realization, AI can help a lot. So as a conclusion in the end, I think, of course, today it looks we as human, we do more, but gradually AI will do more and more. However, we will become the new Homo. And just a quote from Charles Darwin that it is not the strongest of the species that survive, nor the most intelligent, but the one most responsive to change. Okay, thank you, Neil. That's it.
Thank you, Wanyu. I just wanted to point out, I mean, I think what we saw there were two milestones in terms of AI production. I mean, first of all, that building in Shenzhen, 2011, I have heard some ridiculous claims from certain people who were claiming steps at the University of Michigan were the first ever AI generated designs. That's obviously not true by many years. But secondly, I think that the fact that that last project you showed, that is the first generative AI project to be actually constructed. And I think that's hugely significant. But I've got just to say that if any questions anyone has, please send them into YouTube from outside. But I just want to add just one basic question, and that is that you're off to Saudi Arabia. So am I. Maybe I'll see you there. What you're doing there basically is you're actually building things or designing things. So in a sense, you're compared to say Autodesk, which just simply does whatever it does. You know, it just kind of provides the software. You're actually kind of getting involved in the design process with your agents, shall we say? Does that compromise your position too much? Because I guess the problem about that is the workload is going to be, you know, it's going to be a bit eccentric. Some moments you'll be absolutely having to invest in that project. Other times you can't. And when you're trying to run an agent-based AI company at the same time, does that not cause conflicts or things? Or
Yeah, I think I don't know. I wanted to refer to one of our ancestors' kind of advice in the history that the artisans usually make their own tools. So you first need to become the profession. You understand how to make it work, and then you know how to build your good tools. Uh, like example, Tesla. The most powerful thing of Tesla is not just their cars, is how they build their tools, the factory, the system. So we believe this is the way how you can really make good tools. You have to firstly understand how things works, and then you polish your own tool and make it mature and as simple as possible for others to use, and then it becomes something everyone can be adopt easily. Otherwise, before we also created some tools, and we found out, oh, that's our own thinking. It's not really what the users want. So we changed our methodology. We want to use our own tools first, make it really work, then we launch it as a proper product. This is also how it happens to, for instance, LucX and Design Cloud and so on.
so maybe just a question. I mean, of course, the complications that you face. I mean, we had a similar question with the guys from Infrared with Joanna. Uh, I mean, they have a kind of global situation where it's kind of like it applies no matter where you are. They somehow can span the world. But with your particular project, it's very much reliant on the local codes, and so on. So, if you were to kind of give you an overview of the world, it seems like in Saudi Arabia, that is probably the most advanced territory right now where you're developing this. Could you just look at the map of the world, sort of say, well, Saudi is kind of fully on stream now, China's coming on stream, in or is already on stream, whatever. When will will things be available in the States and so on? Just kind of map out your global strategy, should we say? Yeah.
Could you please stop sharing because we can see your
Oh, yeah.
stuff.
Oh, okay. Yeah, I think Saudi is the one of the most popular market right now for all the architects and the relevant entities. And we're not just in Saudi, but also in UAE. Actually, we have our office in Abu Dhabi right now. And we before that we were mostly setting up our entities in China, Hong Kong, and the States. But UAE or Middle East is kind of a combination of the West and the East system, let's say. For instance, UAE more adopt to UK standards or regulations. Saudi are more to the US standards. And we found out there are some like fundamental similarities among, for instance, among Hong Kong to UAE or among US to Saudi. So this is will give us the broader view how different regions will treat their issues, not just the geotech stuff or the environmental stuff. I think also their cultural, their constraint of those regulations and so on. They have different levels, but there are something fundamentally similar. And we can set up this foundation, and then also set up different, let's say, sectors which can be varied by the users. So this is the future step. For instance, the regulation can be easily learned and trained by the AI models today, but how you can integrate with the design generation, this is another thing. So if we can set up the base and set up the similarity among things, then later it will be much easier to go for other regions. Yeah.
Okay. That's interesting to know that you're effectively you're acting as a guinea pig, in fact, with your own work, working on practice to go and find out where the issues are and then
For
developing.
interrupting you, could you please stop the sharing because we can see the WhatsApp and everything.
I see, yeah. So do we have any questions in the chat? Um, if you do have any questions, please send them to the chat. No, it's good to see, get an update each year. I mean, we've been working with XCool for some time, and each year to see the kind of the progress and the challenges and so on. So and it's good to see that you're using agents as part of your approach towards things, which is very kind of the moment, shall we say. Do we have any questions in the chat at all? In the YouTube chat. Okay. Uh, if not, I'm conscious of the fact that it's midnight now in China, and um, uh, anyway, well, okay, let's try and wrap it up. I think, can I just thank Guan Yu and Yuana for their contributions today. This is incredibly useful to kind of to share this information globally. And I kind of think, but by monitoring what you guys are doing, and Theodorus, I should say, Galanis was on the DDES at the FIU with Wanyitu at the very beginning, so we've been closely monitoring it. It's wonderful to see this kind of development and how things are taking place, and to see that now Infrared City is I don't know what you call it now, but it's now being floated as a company, and things are happening, and it's good to see what XCool has been up to as well. Just one final comment. I want to ask you this, just a final comment. As we all know, XCool, or we should know, XCool basically means ex-Coolhaus, and it came out of, in some senses, frustrations of yourself working with OMA and seeing the inefficiencies of the office. I understand that Rem Koolhaas came around to visit you in Shenzhen. What was his response? What was his response to what you're doing?
Yeah, we actually, yes, discussed what we're doing, and he kind of learned what we do before. And I also did a proper presentation to him when he came to us, and I spent 2 days with him and revisiting some of our previous projects, like Shenzhen Stock Exchange. And I think one of the thing is, if I found out our methodology in the beginning may looks a little bit of contradiction. Why is that? Because I keep saying that we want to kind of release the architects and make them less workloaded and so on. And this is a kind of a dual side sword that it will impact in other side, that some of the architects may find their job meaningless. For instance, the drawing makers, for instance. But he also finds it very valuable, because this is how the entire society, the world is changing. And if we are not embrace it as the in-game person, I mean, as the professionals to do the thing, there will be some others coming in to do it. And that might be not the way we want to make it. So think this is a quote of one of your prime minister in UK, that if you want to change it, then you need it, right? And this is what we think, and he's also encouraging us to keep going on, because he even didn't really thought it through how to prevent this discipline, but this is how it goes right now. I still keep thinking of it, actually. And I want us to really guide not just the architects, but guide ourselves to make the right choices to do to, let's say, participating this revolution of AI for all the society. Yeah, it's open question. It's not there yet, actually.
Yeah. Just for the final question. I mean, you're not the only famous female Chinese AI expert. Of course, we have Fei Li, and what's happened in the last year with Fei Li has been quite astonishing. Setting up her world labs and this work on spatial intelligence, which is something that I've been looking at kind of closely. Could you just kind of clarify what it is that differentiates the kind of data that they're looking for in this? I mean, because I guess the problem, just to explain to the viewers, it's easy enough to scrape data for large language models in terms of text and images from the internet. Easy enough, but spatial data, which we have in our heads, it has to be basically synthetically put together. Anyway, so it's quite a challenge to, we live in an age where, with robots and domestic robots and with self-driving cars, this is increasingly becoming the question: how do we develop the sufficient data to service those two sectors? And that seems to me to be providing potentially data for architects in that they're dealing with three-dimensional things. But where is the shortfall in terms of what we need as architects? Where that kind of, I guess, spatial coordinates, let's say, what are they lacking that makes them a little, I mean, we can't use them directly in architecture. Where is the shortfall? What else do we need as architects to supplement that data?
I think there's a different layers of answering this question. First of this world model now to train the robots and the autopilot cars are quite different than the ones, for instance, be generated by Fifini's model for video games. For video games and movies and this kind of visual experience are rough models, and the data sets came from, for instance, the animation models and the 3D videos and so on. But the ones to train the cars and robots, those are precise ones, precise 3D. Just as I mentioned, our AI-driven BIM model, it's this type of a precise model, as well as for BIM or CAD. Those are precise model. So there's a ways to create those precise model. One is by, of course, 3D modeling tools, Rhino, Revit, and so on. Another they are using right now are mostly using the laser sensors to generate precise models. But for Tesla, they even don't think preciseness doesn't really necessary for cars, for instance, because it's not that precisely need to be done. So they changed the laser to the vision. So only using cameras to generate this 3D model similar to the one using for the video games. And of course, when you're scanning you take the photos, then of course you can measure the depths of the image and generate the spatial, or let's say world model for training those things. So in this kind of a automated way of generating data, I don't think architects can really kind of step in. and to work that much with it. But for the ones that need to be precisely trained, for instance, robots, how the robots work, for instance, in the kitchen, is a very precise scenarios. It might need architects to design or create certain visual precise model to train those things, as well as for the industrial production line robots and so on. So this is something I think there's a potential. Yeah.
Okay, I think that's fascinating. Well, there's a lot more to be said. I won't go into it now, but I think this is the kind of area that we're getting with Genie 3 and things where the kind of intuitive information about physics and so on that is somehow these models are learning, they're being self-taught, they're figuring it out, as it were, does point towards the possibility that eventually we're going to get much more precise information coming even from those kind of world models. But anyway, it seems to me that this is really the age of spatial intelligence, the age of 3D in the world of AI, and it's one that really is the challenge that architecture faces. So I expect this time next year we might have some really interesting new information about how there can be some kind of collaboration with the robots in the kitchen kind of thing that might lead towards using that data for an architectural project, should we say? Okay.
Yep.
So if there are no more questions, let's wrap up. Thank you, Wan Hu, for coming on what
Thank
is
you.
a late hour. It's gone midnight in Shenzhen. And thank you very much. It's always good to get this update. Thank you, Joanna, as well. Not so late in Vienna, but that was Mulțumesc. That was great to see.
Thank you. Thanks for the invitation.
Our pleasure. This is the end of this particular series of what, 7 weeks now we had of tutorials, and just want to thank all the people who've contributed towards it. There's a whole team in Digital Futures. Giovanna and Mitra in particular have been doing a lot of work, but there's others as well involved. And thank all the tutors in the whole session, in the whole series, and especially today to thank Wan Yu He and Oana. So. We will be back next year, and with everything we've been talking about will be completely out of date fairly soon. But that's the point. We have to keep updating ourselves, and this was a very useful session today. Digital Futures will carry on with some other sessions, not focusing so much on AI in the next few weeks. And forwards, onwards, upwards. I may be seeing you when you in somewhere in Saudi. Yep. I don't know. I've got to be in Doha and Riyadh and on the coast. I forget the name of the city. Anyway, fantastic. Good. Thank you and thank you and goodbye. Thank you. Thank you for the whole series.
Bye.
Bye. Bye. Bye.
Bye.